Hi! For this next video, we're going to be looking at converting not between mass and moles or particles and moles, but from mass all the way to particles or particles all the way to mass. All right, this is going to be different than the ones we've done before because the problems earlier were one-step problems. This is going to be a two-step problem. All right, so let's look at numbers 5 and 6. So number 5 says, what is the mass of 2.47 times 10 to the 21st particles of SO3? All right, so we've been given particles of SO3 and asked for the mass. All right, so if we think about it in terms of a map, we have 2.47 times 10 to the 21st particles of SO3, and we're asked to determine, well, what is the mass of that amount of substance? All right, we haven't learned any conversion factors that let us go directly from particles to moles, so there's no one step that we can make here. Instead, we're going to need to convert those particles into moles of SO3, and then those moles will be converted into grams. So particles to moles, we're going to use Avogadro's number, just like we did above, and then moles to grams, we're going to use the molar mass of SO3. All right, so before you start the problem, you're going to need this molar mass of SO3, so somewhere off to the side, you need to take your periodic table, look at the molar mass for oxygen and for sulfur, multiply oxygen by 3, add sulfur, and you should find the molar mass is 80.07 grams per mole. All right. Avogadro's number is 6.02 times 10 to the 23rd, so we don't need to do any calculations there. We hopefully just know that one. All right, so we're going to start the problem like we always do with what we've been given. So 2.47 times 10 to the 21st particles of SO3. Our first conversion, particles to moles. Particles needs to go in the bottom because it's on the top here. So 6.02 times 10 to the 23rd particles of SO3 for every 1 mole of SO3. All right, so if we look, the particles are going to cancel and we'll be left with moles, which would be fine if that's what the problem asked us to do. But instead, the problem asks for mass, so we need to do another step. So this is going to be a second conversion step. And we're going to go from moles of SO3 to grams of SO3. So this time the mole needs to go on the bottom of our conversion factor so that it will cancel. And that molar mass that we calculated a few minutes ago is going to go up top. All right, so 1 mole of SO3 is equal to 80.07 grams. Those moles are going to cancel and we're going to be left with the units of grams, which is what the problem asked for. So we've got everything set up. Now we're going to do the multiplication. So 2.47 times 10 to the 21st times 80.07. And then we're going to divide that by Avogadro's number, 6.02 times 10 to the 23rd. And we're going to find that the mass of this amount of particles is 0.33 grams. All right. So again, 2 steps this time. All right. The first step was our particles to moles. And then our second step was moles to grams. All right, so whenever the word mole is not in the problem, you can almost guarantee you're going to have more than one step. All right, so let's look down at the next problem. It says, how many particles of NaCl have a mass of 34.25 grams? All right, so we have a mass and we're asked for particles. All right, so this time we'll start with mass, 34.25 grams of sodium chloride. And we're asked to calculate how many particles are in that amount. All right, as we saw from above, there's no direct conversion factor between grams and particles. So our first step is going to be to take those particles and find moles of NaCl and then take the moles and convert to particles. So grams to moles means we need the molar mass of NaCl. And then moles to particles means we're going to be using Avogadro's number. All right, so the molar mass of NaCl, we need to use the periodic table again. So we go find sodium and we find chlorine, add them together, and we find the molar mass of NaCl is 58.45 grams per mole. All right, so we have everything we need because just as we saw above, Avogadro's number is always 6.02 times 10 to the 23rd. All right, so we look at what we've been given. We have 34.25 grams of NaCl. And we're first going to convert from grams to moles. To do that, we need the grams on the bottom. So the mole will go up top. 1 mole of NaCl has a molar mass of 58.45 grams of NaCl. That's going to allow us to cancel those grams and leave us with the mole. But the problem asks for the answer in particles, so we need to convert again. All right, this time the mole is going to go on the bottom. So 1 mole of NaCl contains 6.02 times 10 to the 23rd particles of NaCl. All right, and if we check, the moles are going to cancel again, and we're going to be left with the units of particles. All right, so now it's just a calculator. So 34.25 times 6.02 to the 23rd, and then we're going to divide that by 58.45. All right, and we should get 3.53 times 10 to the 23rd particles of NaCl. All right, again, just as we saw in problem 5 above, there are 2 steps. The first step this time is to convert from grams to moles, and we did that with the molar mass. And then the second step is to convert from moles to particles, and we did that with Avogadro's number. All right, so those are 2 examples of how we go from grams of a substance all the way to particles, or particles of substance back to grams. All right, there's going to be one final video which is going to look at an additional step that might pop up in these problems. All right, but it's going to have the same general steps that we've seen in the earlier conversions.